want your big calculator out because we're going to be into that. Determine the mean, median, mode, range, all that. So I need you to grab your calculator, and do we remember how to enter the data? So I would go stat, edit, up, clear, down. And then let's enter all those scores in. Okay, so my calculator has all that in it, so I'm going to quit. Now we would go stat, calculate, one variable statistics, enter, and there we go. So our mean is 77.6. The median, MED, median is 80. The mode, you can't really ask your calculator to do that. I can just look usually on here. Do I have anything? Well, 80, 80. Okay, you can look. There is something else I can do. And that would be this. I could hit the stat, and I could go to sort A, L1, the list 1, and it's going to sort in ascending order the list. Done. Stat edit. Now I can scroll through it maybe better and see does anything happen. So 80, 80, and that's it. Nothing else happened twice. So the mode is 80. The range, so on here the max was 99 and the min was 49. So the range is 50. Okay, number 2. When your sample size is large, your margin of error will be smaller. You're going to be more accurate. The larger number of people you survey, the better your data is going to be. If you have a small sample size, then your margin of error will be bigger. Okay, so on your test, I think I had a little chart, and it was like 500 people, 1,000 people, or 200 people, and I put the margin of error in the wrong order. So what would I do to fix that? Which one should go where? What's mixed up? Which one should be the smallest? This one should be the smallest. Then that, and this one was in the right spot. Okay, so that's how on your test, that's how I was asking you the question of, did you understand that? Okay, number 3. We surveyed 2,500 Manitobans about phone lines, home phone lines. The survey results were given as follows. 45% of the people had phone lines. The results were accurate within 3% points, 95 times out of 100. Okay, so state the confidence level. How confident are we? We're 95% confident. 95 out of 100. What's the confidence interval? So the interval would be 45 within 3 points. So can you go down 3 points? So from 42% all the way up to, what's the highest we can go up to? 48%. Okay, basically what I'm doing is I'm taking that plus minus the margin of error. If the population is 1.9, how many people can we expect to have a phone line? So I'm going to do 1.9 million times 42%. And also the same idea times 0.48. Okay, so between this and this many. Okay, remember when you're doing your calculator on this one, I can go second enter and then just go back and change so I don't have to type it all in again, right? Remember that button? Second entry. Okay, so that's how many people in Manitoba we can expect to have phone lines at home. Okay, number 4. Which one of these groups is more consistent? When we are given standard deviation, how do we know when somebody is more consistent? We're looking for the lower. Okay, you're more consistent if your standard deviation is lower. Lower standard deviation means you are closer to the center of the data. A bigger standard deviation means you're more spread out from the center. Okay, analyze these findings. So these are pretty similar. These are pretty similar, the mean and the median and mean. Oh, but these are way different. The range. So what does the range also tell us? If your range is 25, you have probably a really small number and a really big number. So then data A is more consistent. Okay, kind of goes hand in hand with standard deviation. If your range is lower, it means your numbers are closer together. Okay, the normal distribution curve. Your class average was 80. So I'm going to put that right in the center with my mean. Okay, the standard deviation is 4. So if you're one higher, you scored 84, 88, 92. If you're one lower, that's a 76. A 72 and a 68. Okay, on your cheat sheet, you will probably want to have a copy of your, do you remember this thing? So there's 68%, 95%, 99.7%. Do you remember all that? So why don't we, I'm going to pause this video, and why don't we get this on our cheat sheet? Okay, so that, you probably want that on your cheat sheet. Okay, so I'm going to look at this and answer the following questions. So using the normal distribution numbers, find the percent between 68 and 80. So that would be between here and here. So my answer would be 49.85. 49.85. Okay, above 76, so 76 is at the -1, and everything above it. So I want this. So I'm going to have to do a little bit of math here. This zone on our chart was 34. And then what's this zone? The rest of it is 50. So that would make how much altogether? 84% of the data is above that. Okay, below 72, so 72 is at the -2 spot. So the -2 spot is 72. What's below it? So what are we going to do here from the -2? We could add those, or we could do 50% minus the 47.5. That's up to you. You can this, or you can add those two sections. So that would be only 2.5% of the data is in those zones. Okay, between 72 and 88, so we're going from the -2, that's where the 72 is, and the 88, so we went from the -2 all the way to the 2, so that one is which rule? From the -2 to the 2, that is the 95% rule. Okay, between 76 and 88. Okay, so this is what I'm thinking about. So from the -1 to the 2. So from the middle to the 2 over here, that is the 47.5. And then this chunk is 34. So I would add those numbers together. All right, and the last one, we're between 88. So the 88 on our curve is the 2, and the 92, which is the 3. So what's between the 2 and the 3? And that one we have labeled. So that one would be here, 2.35%. Okay, do you see how important it will be that you have a good one of these on your cheat sheet, okay? Because I think I put one of these on there. Okay, what else do we got? Do you want a 5-minute break now and then finish 2 pages, or do you want me to just finish and then have like a break at the very end? What do you want me to do? Break now or just go and then relax? Does it matter? Okay, I'll just go then and then you can have your little break after. Okay, determine the Z-score. So you have a formula that would be like this. Z equals your score minus mean over standard deviation. So I would probably write this on your cheat sheet because I will give you the formula for it, but my formula is gonna be like this. So my formula would look with symbols. So if you want to write this on your cheat sheet, that maybe be a good idea. And then you can write it in words that says my score minus the mean score over the standard. Okay, so here we go. 93 minus 85 over 5. And if I'm typing this into my calculator, I got to be careful, right? If I'm doing this, it will get me wrong. Okay? Do we understand that this is wrong in our calculator? I can't do that. What would I need to do? Brackets or push enter before you divide, okay? So I get a score of 1.6. That's a Z score. So do you understand what that means? It means we're like that. We're above the mean, 1.6. Right? Because our Z scores are 1, 2, 3, or negative 1, 2, 3. Okay, working backwards. The Z score of negative 1.7. What is your score minus the mean over the standard? So now, what is our score? So that's what I'm trying to figure out. So I'm going to do 2 algebraic maneuvers here. What am I going to do? I'm going to times 5, and then I will add 85. So I'm going to times by the 5. Then add. So that's my score. I'm underneath the mean, right? I'm lower than what the mean average would be. Because I'm negative. As soon as you're a negative Z, it means you're below the average. Okay. Determine the percent of data between. So do you remember the calculator buttons for this one? This is all calculator stuff. So we're going to go distribution button. So that's where the vars, you got to push second vars. Distribution button. Normal CDF. And then you have to type in 4 things. Remember how that would always work? Normal CDF, low, high, mean, standard. So my low is negative 1.8. My high is 2.1. And these are z-scores. So what is the mean of a z-score? What's right in the middle of the chart? 0. And what's the standard deviation on the z chart? 1. Right? Because 1 standard, 2, 3. Enter. So 94.6% of the data. Okay, next is what's above. So normal CDF. So we're going to do 0.62. How do we write above? We just say 999999999, comma 0, comma 1. So 27.4% of the data. Okay, how do we do a below? What's the thing to do with the below? Do you remember? You would start with the negative 99999. Okay, so if you're going below something, you got to do the negative infinity first. So negative 9999 up to 2.5, 0, and 1. Okay, now we're going to do the same thing, but we don't have 0 and 1. So it's basically the same idea. So in the next one, you're going to do the normal CDF. Same thing. So above 30, you're going to do 30, and then the 99999, comma, the mean, comma, the standard deviation. So this time, it's not 0 and 1 because our mean is not the z-score mean. Okay, what percent is between? So again, normal CDF, this is what you would be typing, the 4 components, low, high, mean, standard. Okay, so one of those questions is when I give you z-scores and one is regular scores. Okay, this one's one of the maybe harder questions. Given that 10% of the data is below what value? This is what I'm trying to figure out. 10% of the data is below what? Okay, so this feature on your calculator is the button called inverse norm. And the inverse norm, you're always going to do the percent below in a decimal. Okay, so it's under your distribution of your data. So inverse norm 0.1. And it's going to give you a z-score. Now I got to get that z-score back to my score. Do you remember how to do that with the formula? So negative 1.28 equals my score minus mean over standard. Okay, so I have it on there. I'm going to times by 2.6, add 33.7. Okay, and I didn't do any rounding, I just left it on there, so I times by 2.6 and then added. So 30.4. All right, 60% of the data is below what? Okay, so I'm going to inverse norm 0.6. That's what I'm going to do, inverse norm 0.6. And I get a z-score. So when you do that in your calculator, you should get a z-score of 0.25. Now I have to take that z-score and convert it back to an original score. So 0.25 equals what minus the mean over the standard. Okay, so I took all that on my calculator, I times it by 2.6 and added 33.7. Okay, the last one is probably where I would trick people. This one is tricky because 15% of the data is above what? So here is where you would have to catch yourself. What kind of decimal will I put in here? Because the inverse norm always says you have to enter the percent below. So what is below that? So what, can you figure out how to do that? What would you do? 100 minus 15? So 85% of the data is below. Okay? So that's where that would be tricky, that you have to remember. Okay, so I'm going to do that. So Z equals 1.04. Okay, once I get the Z score, I'm going to times by 2.6 and add the 37 again.